Okay. Good morning, everyone. Good morning, everyone. Turn on them cameras because I'm going to call on everybody today, whether you're on camera or not. Okay, here we go. Admit all. All right. Oh, there we go. Excellent. Wonderful. Wonderful. Okay. All righty, let's get started, folks. Daytona, Addison, Reese, Sierra, Boston, Corey, Aiden, and Michaela, if you would, I'd appreciate cameras on, if possible. Now, with that, I have a question for you guys. This is the easy question, so you might want to hop in. If I go to Menards and I buy a 12-foot extension cord, how long is the extension cord I just bought?
12 foot.
Nailed it, Daytona. Good job. Okay, so what happens if I go to Menards and I buy a 25-foot extension cord? How long is the cable?
How long is the cable? It's 25.
It's 25. Okay, great. Now, here's my question. I take my 12-foot cable I just bought, a 25-foot extension cord I just bought, and I lay them out next to each other and plug them in together. Now, how long an extension cord do I have?
37 feet.
Nailed it, Addison. Thank you. Yes, 37 feet, because here's what I did. I took this cord and I just added them together. Same thing for segment addition. If I have those segments like we talked about yesterday, little segments, here's one, and I go, boop, put them together and make one long segment. We call that segment addition postulate. Now, you'll notice that math people are super creative with their names. We took segments, we added them together, we called it the segment addition postulate. Now, let's go the other way. Mr. Moore bought a 100-foot extension cable, which is true. I have a 100-foot extension cord that I use for my hedge trimmers, that I use to trim my Rosa Sharon and my boxwoods out in my lawn. Okay. Unfortunately, I don't have a 100-foot of cable anymore. I have a 43-foot extension cord. What do you think happened?
It subtracted.
I subtracted. How do you think I subtracted on an extension cord with hedge trimmers?
You cut it?
I did, in fact. Yes, I was, and it went right through, and it sparked a little bit and left a little burn mark on my thing. That is not a cat. Wow. Okay, there we go. That's a cutie right there. All right, so with that, I did subtraction now. So I had a 100-foot. I now have 43. What's the other extension cord that I now own?
A 57 foot.
About 57 foot, because what postulate did I just use?
The subtraction.
Nailed it. Segment subtraction postulate, yes? Segment subtraction, because I subtracted 43 off that 100 foot. Okay, I can do the same thing with angles. Let's say I got this big O angle right here, but then I take part of it off. Take this part off and it's now only this big. Well, what postulate do you think we'd call that?
Subtraction segment.
You're so close. It was an angle. So instead of segment subtraction, we're going to call it angle subtraction postulate. Does that make sense, guys? Cool. All right, so addition and subtraction of segments and angles. So let's go on to something like this. Why don't you take a look at this problem right here? See this problem? I want to add segment AB, which is 3x plus 2, and segment BC, which is 2x plus 8. I want to add those two segments together. How long is segment AC? How long is the whole thing? Who can tell me what to do?
You add,
Combine terms.
Perfect.
Yeah.
Daytona says add. Danny says combine like terms. They're both 100% correct. Somebody who hasn't talked yet, tell me, how long is segment AC?
5x plus 10.
Perfection. Was that Felicity? Good job. 5x plus 10. She said, I'm going to take this x here, I'm going to take this other x here, I'm going to put them together. Take this 2 here and this a here, I'm going to put them together. So the answer is 5x plus 10. Now let me give you some more information. Look at this OG PowerPoint. There you go. If I tell you AC is 30 units long, AC is 30 units long, could you find x for me? How would you find x for me, ladies and gentlemen?
Because it tells what A and C are.
Okay,
How long
because
is
I
it?
now know what A and C are. So could I do this? Could I say 5x plus 10, which is what Felicity told me, and set it equal to the 30 that I know how long it is? Could I do that? Everybody go to your paper and your pencil, find x, go. Get your paper and pencil and find x. I know it's not fair to have paper and pencil in a math class. Hey, Clay, here in a minute, I'm going to ask you what the first step is, okay? So be ready.
Oh, 1 second. I'm trying to get a paper and pencil.
Oh, well, that's fair. Boston, I'm going to ask you what happens after Clay tells me what's next. So go ahead and solve it if you haven't already. Clay, can you tell me what to do first? Clay may be going to get his paper. Boston, can you tell me what to do first?
Yeah, I'm not too sure.
Okay, well, I got me an equation. I want to get x by itself. How do I get rid of this 10?
Do you move it to the other side?
Yes, by doing what?
Subtracting.
Perfection. So we're going to subtract 10 from both sides. So Boston, once I subtract 10 from both sides, I got 5x equals 20. Now what do I do?
Divide.
Divide by 5, and my answer is going to be?
4.
Nailed it. Thank you, Reese. Good. Since you guys are so smart, tag. Here's your new problem. Find x. Somebody who hasn't talked to me yet, tell me what the first step is. So Corey or Michaela or Elijah or Esther, what would I do first? You can type it or you can say it.
Move your constant to the right.
Move the constant over to the right. Okay. But to do that first, I'm going to have to put it together. So what's 2x plus 1x, folks? Oh, boy.
3x.
3x.
Good job, Elijah. Way to get on that one. Okay, 3x. Then it's going to be what? What happens when I put -1 and +7 together?
You get 6.
6.
Good. So I got 3x plus 6 equals 3x plus
35.
6 equals. Ooh, how long's the whole thing?
45.
45, you betcha. So now I can have an equation, and he's 100% right. We move that 6, put that constant on the other side by subtracting. Then I divide by 3, and x equals 13. How many people got x equals 13? Yay! Okay. So segment addition, segment subtraction. We okay with that one? Now, here's the other problem, though. Remember I asked you at the very beginning, I asked you, hey, how long would a cord be if I bought a 12-foot cord? You said, hey, 12 feet, which is correct. How long is a foot?
12 inches.
12 inches. How big's an inch?
10 millimeters.
It is not 10 millimeters, but that's a good guess. Here's a question. How many of you, I want you to put in the chat, would you rather run a mile, 1 mile, or would you rather run 1 kilometer? Put it in the chat.
I don't know
Oh, Danny, why don't you know?
because I don't know how long a kilometer is.
You are right. That is the correct piece of information that you need, right? You say, I don't know how long a kilometer is. Now, we only know how much a mile is because we're kind of used to it. But for all those people that want to run a mile, were you aware that a mile is 5,280 feet, while a kilometer is only about 3,300 feet?
So it's like a half mile?
It's a kilometer is a little over a half mile, yes. So probably you're going to want to run a kilometer unless you're just like enjoy running and you're like, woohoo, extra running. Okay. So here's the thing. We need to know which measurement system we're even using. You'll notice I told you on this that it was 30 units long. I didn't even tell you what kind of units, did I? Okay. So we need to figure out, where did units come from? What types of units are there? And that's why you have homework that's on slide 5. Okay. You have slide 5 that is talking about slope and talking about units of measurement and talking about congruence. Now, you'll notice segment addition over here. Let's talk about a few more words, because you'll notice geometry is all about definitions. We talked about this yesterday. It's all about definitions. Does anybody know the definition of the word congruent?
Doesn't that mean like all things are equal or something like that? Like they're like the same?
Okay, yes. So for example, if I have 2 triangles, here's a triangle and here's a triangle. If they're congruent, they're going to be the same size and the same shape. So all those angles are the same. All the side lengths between the 2 are the same. So that's congruent. Now, how is congruent different than equal? Does anybody know how congruent is different than equal? Yawning. Think about it this way. If you have identical twins are congruent because they are the same shape and the same size. If they're identical twins, same shape, same size. Now, the only way you could ever run into somebody that is equal to you meaning exactly the same as you, is if you traveled back in time and met yourself. Only then would you be equal because something is the same thing. Okay, so equal means it's exactly the same thing. Segment AB, segment BA. It's the same exact segment. They're literally the same. It's equal. Versus segment AB is 6 inches long. Segment BC is 6 inches long. Those two are not equal. I'm sorry, segment AB and segment CD. Those are congruent because they're two different segments that happen to be the same length. Now, let's talk about similar. Okay, if we took Donald Trump, the real one, and Donald Trump and made an absolute miniature of Donald Trump, that is not equal because they're not both Donald Trump. They're not even congruent because even though they're both the same exact shapes, they're not the same size. What word is it that we use to indicate same shape, not necessarily same size? What math word do we have for that? Similar. The word is similar. So just a couple definitions before you do your homework this evening. Your homework this evening is slide 5 and 6. Slide 5 and 6. Okay? Make sure you're following the directions. Make sure for your Delta math that you are submitting your work, because if you're not submitting your work, you're going to get a 0 on the Delta math. Do you understand? Okay.
Isn't it due on the 12th?
What's that?
The Delta math, isn't it due on the 12th?
That may be when the due date is, but when should you have it done by? Tomorrow. Why? Well, here's the deal. I set those due dates for when we potentially will finish the chapter. Okay, so let's say you have a bad internet connection today and you can't do this tonight. Are you still able to do it tomorrow to get 100%? Yay. But if you don't do these tonight, you don't do those tonight, you don't do those tonight, and then tomorrow you don't do these, and you don't do these, then you're falling behind, folks. So I do want you to keep up and do what's on each slide every day as much as possible. So when I get to tomorrow, when I put grades in at the end of tomorrow, I'll just figure out where the last red X was or the red arrow was, and I'll put all the grades into the grade book at that point. Okay? So just because it says the 13th doesn't mean you can wait that long to get it graded. Does that make sense, guys? You're supposed to do math every day. That was a great question. Whoever came up with that question, that was a great question. Hey, welcome up, Aiden. All right. So there you go. That is our homework for today. That is our homework for today. Does anyone have any questions or struggles or troubles that I can help you with? Okay. If not, have a good day, guys.